Hey guys, welcome back to the channel. In our previous lectures, we learned about various feature extraction techniques, which includes bag of words, TF-IDF and word embedding. Now, in today's particular video, we are going to learn about RNN, which stands for Recurrent Neural Networks. So, let's get started. So, RNN was the first neural network in the field of NLP. Let's start to understand RNN with an example. Suppose the sentence is Love have I pizza day to every. Did this make any sense? Not really, right? The incorrect sentence is Love have I pizza day to every, and correct sentence is I love to have pizza every day. This makes perfect sense. So if reading a wrong sentence is challenging for the human brain, imagine how challenging it must be for machine to encode, right? Now we can understand that sequence or arrangement or order of words in this sentence is extremely important. Sequential data includes things like time series data, text data or speech data. Let's take an example to understand recurrent neural network in layman term. So, have you ever noticed how we humans perceive or grasp each sentence? Suppose the sentence is My name is Yash Patel. So how we can interpret it? How we can understand this sentence? By interpreting previous words for the particular sentence, right? In our example, suppose sentence is My name is Yash Patel. So question will generate what is Yash Patel? So answer is it's a name of a person. Now whose name? So answer is my. So that's how we interpreted the entire sentence. Here you can see we take a reference of previous word to understand the particular word or understand the whole sentence. Here you can see we understand Yash Patel by the previous sentence, previous word name. Now we understand name by previous word my, and that's how we interpreted entire sentence. So RNN helps machine to solve this kind of sequential task. Okay, here some of the use cases of RNN. Suppose first use case is sentiment analysis. So we have a review of a product and we need to identify whether a sentence is negative or a positive. So suppose example is this is very nice t-shirt. So answer is this is positive sentence. This is not a premium shoes. So obviously this is negative. Second use case is language translation. Right. Here suppose English to Hindi. My name is Yash Patel and the translation in Hindi is Mera naam Yash Patel hai. The third use case is text summarization. In text summarization you input the whole article or a whole PDF book or big corpus and you just want to summary of that particular input. So this is the use cases of RNN. Another is grammar correction. Here you can see the spelling of conscious is wrong. So it suggests the right spelling. The another use case is rephrasing sentence. Here you can take an example that please contact me if you need more information. So here you can see the various phrases of particular sentence, or we just type in another way of this sentence. Here you can see please contact me if you require further detail. Please get in touch with me should you require further information. Please reach out to me for more information. So the meaning is same, but the syntactical formation of a particular sentence can be different. Other use cases like chatbot and virtual assistants, text classification, grammar checker, auto spell correction, text generation, language modeling, name entity recognition, topic modeling, and many more. So you might be thinking about Why do we need of recurrent neural network as we already have a traditional neural network? Suppose feed forward neural network. So as you know, in a feed forward neural network we have a input layer, we have a hidden layer, and we have a output layer, and each layers are connected with each other. Each node also connected with each other. So you might be questioned why recurrent neural network is found, as we already have a traditional neural network. But as before you see, the sequence is really important to understand each sentence, right? So that is the major problem in traditional neural network, that it doesn't have a memory. Here you can see the primary reason is in traditional neural network all the inputs and outputs are independent with each other. It does not have an idea about the previous or a next word, as it does not have a memory to keep a sequence or a order of each sentence. Right, hope you got the idea why traditional neural network is not useful for the sequential data. The second major reason is in traditional neural network we have a fixed node for the input or a output. Suppose the sentence is like shoes is not flexible, and the second sentence is this t-shirt is very comfortable and premium. So here you can see when we feed the first sentence in a traditional neural network, you got the four input. Shoes for the first node, is for the second node, not for the third node, and flexible for the fourth node. Like here you can see, as you know, we have to convert entire text into the vectorized, or we can say numerical form, as machine cannot understand text data. So here you can see we converted entire sentence into the vectorized format. Now here you can see input is 4. But what about the second sentence? Here you can see second sentence has more than 4 words, right? So solution is find out for maximum length in the data and then adding 0 at the end of sentences to equalize every sentences, right? So which means we can find out the maximum sentence of the all data, and according to that length of maximum sentence we can add zeros to other, or we can say less rest of data. But it is not efficient and also inaccurate, right? For the better accuracy of model, we cannot get the better accuracy if we do such kind of things. And that is how RNN is very much useful instead of traditional neural networks when we talk about the deal with the sequential data. Now let's understand about RNN architecture and how does it actually works. So RNN are networks that have a loop and allow past information to be retained, and that is the major functionality of RNN. Here you can see this is the main RNN structure, and when we unroll this RNN, so you can see it can unroll like this. So here we give an input, we got the output, and this output also be input for the next neural network, right? And that is the functionality to persist the past information of a data, right? A neural network, or we can say recurrent neural network, is made up of several replicates of the same network, each of which sends a output to the next one, right? As I have told before, the same thing that it perceives the output of the previous networks and take as an input, right? Here you can see the animation of entire RNN architecture. So it's unroll, and finally we get the output, right? Here RNN is working on forward propagation over the time, which means on a each timestamp, like here on a t1, the second timestamp is t plus 1, right? On each timestamp it goes forward direction, and each timestamp we take a input of one word for the particular sentence and pass it to the neural networks, right? Here you can see on a t1 timestamp we pass the input of x0 and pre-processed in between in neural networks. Like here a means the activation function, and we finally got the h0 as a output, and this h0 output also be the input of the next networks along with the another word x1 on a t plus 1 timestamp, and this goes till the final output layer, right? Hope you got the idea how RNN is working, right? Here we can get the better understanding. Suppose, as you know, entire neural network, or we can say machine learning, work on the simple linear formula, which is y is equal to wx plus b, where y is the output, w is the weight, x is the input, and b means bias, right? So here you can see we have to initialize the weights along with the input, and we also initialize the bias. There are various weight initialized techniques which will be seen in another machine learning or a deep learning series, right? So here you can see for finding the h0 we use this kind of internal computation. Here x0 is the input multiplied by weight 0 plus b0 means bias, and we got the h dash 0, and finally we applied the activation function on h dash 0, and we got finally h0. And for the here h1, here the formula goes like this: h1 x1 multiply by w1, here you can see w1 plus x0, which is the input output of previous network, multiply by w dash 0, which is the weight, plus b1, and we got the h1 dash. Here is the typing mistake, h1 dash, and finally on a h1 dash we apply activation function to get the h1, and this process goes like the till the output layer. I hope you got the idea of how RNN is entirely work internal computation. Suppose we need to perform a sentiment analysis for the product review. Here we have a sentence like this is very nice product. So here you can see we apply this word as a x0 on a t1 timestamp, right? And as you know, the machine cannot understand the text data, so we have to apply some feature extraction technique to vectorize that particular word. So here, as I have told, you have to watch out my previous videos on feature extraction techniques, right? Which includes bag of words, TF-IDF, and word embedding. So here I vectorize in a very one hot encoding formation for the word this, and we input to the x as a x0 to the a, and we got the h0. We likewise we apply each word at each networks by performing the vectorization. This vectorized form of this word we multiplied by the weights, and finally we apply on a activation function on it, and we got the h0. Here h0 we get in a vectorized form. So this value is hypothetical, right? I hope you got the idea how it is entirely works, and this hypothetical value of S0 is multiplied by the weights and be the input of another networks, and here the second word goes as an input on t plus 1 time stamp and a vectorized formation, and that is multiplied by the output of other previous networks and apply activation function, and we get the h1, right? And that's how the entire process goes, right? Now here the major problem with RNN is gradient vanishing, or we can say exploding gradients, right? So what is it? So suppose we need to predict the last word in the rocket is going in the, and we need to predict what word will be in the blank, right? So here it is obvious that the next word is going to be space, right? So in such case, where the gap between the relevant information and the place that it is needed in a small, here you can see the sentence is too small. So RNN can learn to use the past information. So RNN can able to predict the this kind of next word problem statement. So here you can see the gap is too small, right? So RNN can able to learn the past information. But in the case of long sentences, suppose the example is I live in India. After completing my graduation in USA, finally I got a job in Canada. So I moved in there. So where am I right now? So obviously answer would be Canada, as I got a job in Canada, so I have to move there, right? So here it is entirely possible for the gap between the relevant information and the point where it is needed to become very large. And unfortunately, as that gap grows, RNN become unable to learn to connect the information, right? Here you can see the gap between these two is very big, so RNN cannot remember the past or very past information, and these problems told gradient vanishing, or we can say exploding gradients. To overcome this issue, we have another neural networks which is called LSTM, long short term memory, which we will see in a next lecture. I hope you understand everything about RNN in a proper way. So if you find this video informative and learn something new, then please hit the like button, share this video with your friends who also interested to learn in NLP, and subscribe this channel.